You know how to generate the unit circle right now based on the different triangles we've been using. What were the different triangles we've been using? 30, 60, 90 and the 45, 45, 90. The unit circle that we are going to use is going to be based off of that. So, if I draw my unit circle, I'm just going to start by drawing a circle with that in place. The first angle that I'm going to put in here is about like that. How big is that angle? Roughly? What do you think it's supposed to represent? 30. It doesn't quite cut it in half, but it represents a 30-degree angle. If I asked you for the reference angle for that, that would be 30 degrees, would it not? Which is a 30, 60, 90 triangle, isn't it? How long was the short side in the 30, 60, 90 triangles that we were working with? A half. The short side of that triangle, if I drop that straight down here, that would be the half there. That's the y coordinate, because it goes up or down. What was the medium side of that 30, 60, 90 triangle then? 1. The square root of 3 over 2, which would have been the x coordinate. Guess what you just came up with? You just came up with the ordered pair. Now think of that stuff that I gave you the other day where I had like y over r, x over r, y over x, and then they're reciprocals. Could that be useful then? Instead of having to make the triangle every time? If you know what angle it's referenced at? You bet. Then, let's use a different color. Let's use green. What angle do you think I tried to hit there? 45. Yay. In the 45, 45, 90 triangle, remember the radius was always 1 for these. When I worked backwards, does anybody remember what the sides were? If you don't remember, what's 1 divided by the square root of 2? Can you add the square root of 2 on the bottom? No? So then when you multiply it by the top and the bottom, what do you get? You get the square root of 2 over 2. And remember, it's an isosceles triangle or a 45, 45, 90, meaning they should be the same distance, right? Very good. Let's see, let's go orange. What was the other one of the big 3 angles that we used? I gave you a hint. I already wrote it up there. 60. Now, I have a quick question for you guys because you guys are pretty intelligent. If I have the 30, 60, 90 triangle already drawn up there in the red, now I drew the 30, 60, 90 in the orange in a different location because I use the 60 as the reference angle now. Aren't they the same size? What's different about them? Yeah, the x and the y flip around. So this particular one's going to be at 1/2 and then root 3 over 2. That's what's going to be different about it. Now, one other parts that I want to make sure that I put on here too is this is at 0 degrees, and that would be at the ordered pair 1, 0. And this would be at 90 degrees, and this would be at the ordered pair 0, 1. Okay. Are we okay with those 3 angles, though, that I put up there? The 30, the 60, and the 45? Guess what I'm going to do now? I'm going to use the power of reflection. You guys know what reflection means? To flip it over? And I'm going to create the other side of this thing. I'm going to create the entire circle, the main ones, based off of reflection. That's all it is. If I put a reflection line right over the y-axis, I'm going to reflect it over, so I'm going to grab my... let's stick with orange. What would the reference angle be for that one that I just tried to draw? What do you think? 60? Does that look about a 60-degree angle if I made it down with the x-axis? Okay, how big is the angle itself? If I have a reference angle of 60, how big is the angle itself? $120. Very good. This is a 120-degree angle. Does anybody have any idea what the size are going to be for this? The order pair that would represent a 120-degree angle? I'll give you a hint. Use reflection. Is the 120-degree angle, which would have a reference angle of 60, be the same as the one over here that was 60? Would it be the same size? Yeah. What's different about it? The x has to be negative. Why, Reese? Yeah, I went to the left. Right. It's that simple. These two pieces are the same. The only difference is I went to the left a half and up root 3 over 2 this time. So therefore I am back or negative half, up that much. Okay, now let me grab my green one. Wondering why I'm color coding this to make it so that you can see this. Wop, 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 wop. Which one does this one match? Right. But how big is it? If my reference angle is 45, what's 180 minus 45? Yeah. 135-degree angle. Now, Reese just told us the trick to this one. If these ones are positive, it has to be a negative for the x because we went to the left. So I am at negative the square root of 2 over 2, square root of 2 over 2. On the unit circle that you printed, Reese, did it have those ordered pairs along with it? Don't remember? Some of them do and some of them don't. So. Now let me grab my red one, see if you guys can figure this out yet. Wop, 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 wop. What one does that one match? It's 150 degrees. It is. That is correct, Miss Fisher. But what's the angle match on the other side? Right. Do you think there's a reason why I color-coded it so that the 30s were the same color and the 45s were the same color? Probably. Now, again, like Reese said, the x has to be negative. So this ordered pair that's going to match this is negative root 3 over 2, positive 1/2. Nice work. Now, another thing that I did not put on this unit circle, just because I just don't have enough room in here, I really don't, would be every one of those I'm putting in degree format. Am I not? Something else that might be beneficial to you is that you put the radian measures along with the degrees. If you're going to draw your own unit circle, the radian and the degrees, put them side by side, then put the ordered pairs. It probably would be a beneficial thing. If you don't have it, like Reese said, he printed one out. Maybe he has the degrees there and he has the ordered pairs there, but not the radian measure. Add the radian measure in on your own. Or if it has the radian and the degrees, then add in the ordered pairs. Or if that doesn't have it, find a better one that has all three. Okay? All right. Now, I have the top half of the circle done. Do I not? Guess what I got to do now? Right. Save some time. I'm going to do both the red ones at the same time. How big would the angle be that's in quadrant number 3? Well, this would be 30 degrees for the reference angle, but how big is the angle itself? How much? 210. Because 180 plus 30 is 210. If I am in quadrant 3, that means both my x and my y have to be negative, right? So my numbers that match with that would have been negative root 3 over 2, negative 1/2. If I'm down here in quadrant 4, my reference angle is 30, but that's taking away from it. What's 360 minus 30? 330. Which would be time for me to go home. If I'm in that one, I'm at root 3 over 2, negative 1/2. Because I went to the right, but then I went down. Now I'm going to go grab my green one. Oh, that one might have been the best one. Which ones do those green ones match? Have you guys figured this out yet? There's a pattern to it.
45.
So if I had 180 here and 45 more, what's 180 plus 45? If I had all the way as 360, but I cut out 45 degrees, what do I have? 315. Good. Now, I already know the numbers. It's negative root 2 over 2, negative root 2 over 2 for this corner. And on this one, I got positive root 2 over 2, negative root 2 over 2 because I went down. The last color that I have not figured out is the orange ones. Bum, 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 bum. Bum, 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 bum. How big is this angle? If my reference is 60, what's 180 plus 60? 240. If my reference angle is 60, and 360 would be an entire thing, 360 minus 60 is 300. If I'm in quadrant 3, that means both of these have to be negative. So I am at negative 1/2, negative root 3 over 2. And if I'm in quadrant 4, I am at positive 1/2, negative root 3 over 2. Whew! Now, the reason why I gave you this now is because everything we've been doing so far have been dealing with this unit circle. We've been just dealing with in triangle form. All I've been doing is just making triangles out of every single one of those. Now, today what I'm going to be doing is I'm going to be giving you the answer, and we need to work backwards to figure out what the degree is. That's what's going to happen. I'm going to give you the answer, like the ones that we had, negative 1/2 was the answer. I want to know what degree it started at. That's what's going to happen. Now, one other ones that I almost forgot to put in here. This one's at 180 degrees. If you're at 180 degrees, you are at negative 1, 0. And this one down here is at 270 degrees, which is at 0, negative 1. Okay? That is your unit circle. Other than me putting in the radian measures, which I just didn't have enough time to put in there, or space, you might want to have the radian measures alongside of the angles, just so that you knew how big they were in case you run into them. Okay? Or you do what we have been doing and convert those into degrees, and then you just use this. It's your choice. All right, so here's what it's going to have you doing. Okay, what we're going to be finding is what we call inverses. Okay? We're going to be finding the inverses of all these things, because what I'm going to be doing is giving you the answer, and I want you to work backwards to find the angle. Okay? So here's how it works. If you're going to find the inverse of the sine, which is also denoted as the sine to the negative 1. Okay? That's the sign, or that's how you denote that using some of the terminology. The two zones that we are going to be searching for, or looking for the inverse of the sine, are going to be quadrants 1 and quadrant 4. We are not going to look at any of the other two. So what I'm doing by telling you this is I'm cutting half the circle out of play. All right? So that way we don't have to look at the entire circle, we only have to look at half of it. So I'm eliminating some things for you. Okay? Then if we go and find the inverse cosine, we're at the cosine to the negative 1. When we go to find that one, I'm going to put this in a different color, put it in green. We look at quadrants 1 and quadrants 2. We look at the top half of the circle and nothing more. So if my problem says cosine, I'm just looking at the top half of the circle. If my problem says sine, I'm looking at the right half. Then the last one that it's going to have you doing is it's going to have the inverse of the tangent. Which, if you haven't figured this part out yet, it'll be the tangent of negative 1. And the two zones that you look at are these two over here again. So the sine and the tangent are the same zones that you look at, where the cosine is the top half. The question came up second hour. You do not use the left half, nor do you use the bottom. Okay? So we're not going to look at those at all. So when I ask you these questions now, I'm going to give you the answer, and we've got to work backwards to figure out what degree that was at. That's what's going to happen. That's how your assignment is today. Okay? So it's going to say something like this. It's going to say the sine of negative 1, or to the negative 1, 1. So if that's my unit circle, which you guys have your unit circles, or if you don't, you are going to get one. And we're going to look in this area. Because why are we looking in that area down there? Because it says sine. Right. That's the reason why we're going to look at those, because we have sine. Good job, Matt. Now, the other thing that you need to be aware of is the fact that the sine ratio itself was y over r. That was the ratio. I gave that to you, was it yesterday or 2 days ago? 2 days ago. Okay? What's the radius for every single one of these? 1. And I saw some people holding up one finger, and that's good. Proud of you. Now, out of these two areas, so all these angles that go all the way from here to there, which one of those ordered pairs that I gave you today has a y-coordinate of 1? The reason why I'm asking you that, hold on a second before you guys get too far into looking. The reason why I said, why does it have a 1, is because if my bottom number in my ratio is 1, in order to make 1 here, it'd have to be 1 over 1, right? It couldn't be anything else. If I put half over 1, that's not 1. That's half. So the reason why I knew I'm looking for this is because I needed to make this, when I reduced it, equal to that. So which area, or which spot, has 1 as the y-coordinate?
90 degrees.
90 degrees. Way up there. If you look at my unit circle that I have drawn over here, and I'm looking at these particular spots, this has a negative 1, not positive 1, right? No, 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 yes. So my answer for this problem is 90 degrees. That's my answer. That's the angle that you started with. Now, not only do they want you to give me the angle in degree form, but also in radian measure. If you don't have the radian measures down, then you multiply it by pi over 180, which gives you 90 pi over 180. What's 90 over 180 reduced to, though, Isaac?
1 over 2.
1 over 2, right? So that's half pi, or pi over 2. That's my answer. Okay, let me give you another one. Cosine, negative 1, 0. The cosine is the ratio x over r. What's the radius for every single one of these problems? 1. Very good. So if I know I have a 1 in the bottom automatically like that, what number would I have to have for x in order for it to be a 0 in the end? 1 divided by 1 is not 0. Try again. 0. Right. I have to have a 0 in this hole right there. Okay? When I am with cosine, because that's what we're dealing with, in the unit circle, cosine is the top half. That's what I'm looking at. Which one out of the top half have an x coordinate of 0? 90 degrees again. What was the radian measure for that? Pi over 2. Do you see where they're having that radian measure along with the other stuff in your unit circle could save you a little bit of time? If you had that, wouldn't you just list it? Okay? All right. Let me give you another one. Tangent of -1, -1. On the unit circle, what side are we looking at when it's tangent? The right side, yes. Some of you know it and you say it to yourself or mouth it, but don't want to ever say it out loud. Okay? So that's the side I'm looking at. So what I do, honestly, this is what I've done in the past for me, and it's not going to work because I've got a screen where you're going to see it, but what I've done when I've looked this stuff up is I've actually just taken like another sheet of paper or a scratch sheet of paper or something and covered up that side. So I don't get lost in all the stuff. So that way I'm just focused on the right-hand side. Now, my answer is -1, and we're tangent. Now, a tangent means y over x. And it has to be negative. So in that case, that means 1 negative, 1 positive. Right? If I'm up here in this quadrant number 1, that's not possible. Because all the ordered pairs that I gave you in quadrant 1 were positive answers, right? And Kaylin, if I take a positive divided by a positive, am I ever going to get a negative? No. So guess what I just did? I eliminated this section out of the picture too. So now I'm only focused in the bottom right-hand corner of the unit circle or in quadrant 4. Okay? Other than the Super Bowl, it's the only other time I write Roman numerals. Now, think about the numbers that I gave you. All those ordered pairs. We want the answer to be 1. When you divide, how do you get a 1? When you divide by the same number. And in order to get -1, it just has to be one of those has to be negative and one of them has to be positive. Right, Isaac? Isaac, looking at the unit circle, or did you write one down? You didn't? Okay. Kasha, would you help me out then? Since I saw you wrote one. Did you get all the numbers down? Yeah. Okay. In quadrant 4, which ordered pairs have the same numbers, just one of them negative, one of them positive? What angle? 315. Awesome. And then after that, you convert it into radian measure also by multiplying it by pi over 180. 315 over 180 reduces down to 7/4, right? So 7 pi over 4. That's how you do the first half of your assignment today. All right? That's how you do it. The second half of your assignment is going to look like this, where it's going to tell you some things, but it's not going to work out nicely like it has been. It's going to say something like this. The sine, -1, 0.18. You don't have that ratio. On that unit circle, it's not on there, and nor will it be. Unless you really get in depth with those, but most times unit circles are only with the 30, 60, 90 and the 45, 45, 90. It will not be on there. This is all calculator work. That's all you need for this. You need a scientific calculator. If you have a scientific calculator, you can do this. Here's how you type this in. you go second sine, which if you do that on your home screens, does it not come up as sine to the negative 1? Brianna, even yours has that. And then you type in, if you wanted to, 0.18, or you just put 0.18, either way, equals. Michaela, what'd you get? 10.36, so 10.4 degrees. Done. The inverse tangent of 2.6. So what do I type? Second tangent 2.6 equals. What do I get? So what, Matt? 68.9. Okay. Now the trick to that is you got to make sure your calculator's in degree mode. If it's not in degree mode, it's going to give you the radian measure of it. We want it in degree mode. Now, there is one other little section that's off of this too that you're going to use your calculators for, but they're going to restrict it. What they mean by that is that they're going to go on and now say something like this, where it's going to say the cosine is equal to negative 0.82. But it wants it to be from 180 to 270. So first of all, I need someone to tell me how big the angle is. Someone take inverse cosine negative 0.82 and tell me how big the angle is. 145. Isaac, if I drew 145, I'd be somewhere over in here, right? Now, the restriction that it gave you right here, it wants it in this zone. Is 145 in that zone? No, it's not. So here's how you solve this. When it says that it wants it in that zone, but my angle was right here, what we have to do is come up with another angle that has the same reference angle. So if you said it was 145, is that what you said, Isaac? What's the reference angle to 145? 35? So that means I need to draw an angle down here that has also the same reference angle of 35. How big would that angle be? What's 180 plus 35? So that's the right answer. So what you do is you find the reference angle, and then you have to put it in the quadrant that it says. This quadrant 1 is from 0 to 90. 90 to 180 is quadrant 2. 180 to 270 is quadrant 3. And 270 to 360 is quadrant 4. Okay? So a lot more of this stuff is going to be, though, with your calculator than what you've ever had. So on page 878, we're at 4 to 28 evens.